In this video lecture, we're going to discuss epsilon NFA to DFA. So just a review, NFA with null or epsilon move or epsilon transition means we could transfer to to the other state without consuming or without transmitting a new or without considering an input symbol. Okay, this is an example of epsilon NFA. So there's a transition of epsilon wherein it could move from A to B without any symbol, same as with B to C without any symbol. Okay. And if we want to convert this into NFA or DFA, we need to consider all possible paths. Okay. So let's consider A first, all path, considering all inputs, then followed by B, all inputs, all paths, and same with C, all input, all path. So this is an example of a transition table that shows all paths considering A, B, C state. And also, when we convert epsilon NFA to NFA or DFA, we need to consider the A closure or epsilon closure, wherein it states that it includes itself and the other state that it could reach through epsilon transition. Okay, so going back to this example, so epsilon transition for E closure for A or epsilon closure for A is itself, okay, first, and the other state that could be reached through epsilon transition. So we could reach B since we have an epsilon here. So B will be part of A transition, A closure, and another epsilon here. So therefore epsilon epsilon could reach C. So therefore C is part of the closure of A. So E closure of A is ABC, while for B itself and C. While for C there's no epsilon after C, so therefore it will just itself. Okay, so now let's move on in determining the transition for each state. Okay, so same as with NFA to epsilon NFA to NFA, we're going to create a transition table for DFA. Okay, so let's consider first the path for all inputs considering state A, state B, and state C. So let's start with A. So state A, we all know that the epsilon closure of A is ABC. So we're going to determine what will be the next path considering all the state in the A closure of A. Okay, so let's consider A first. If it's 0, it could reach B and C. So we have BC. And what is the A closure of BC? It's just BC. Okay, so B closure of B is BC and closure of C is C. So BC union with C is just C. Okay, so B at 0, there's no path for 0 at B, so therefore dash dash, and at C for 0, it will just loop within itself. So that's why C and C closure is just C. And at B, okay, at 0, again, there's no path for B, but for C, it could loop within itself. Okay, again, we have two state for closure B, so that's why we need to consider two state here. Okay, and for C, closure C is just C. And at 1, again, we have three states for the E closure at A. So if it's 1, it is just loop within itself. So we have A, and since it ends with A, so it could reach other states aside from A. includes BC through epsilon. So that's why the final path for A at 1 is ABC. Okay, while for B at 1, okay, so loop within itself, but B closure is BC. So that's why we have BC here as the final path for B at 1. While C at 1, so just loop within itself. So the final path will be C. Okay, so while for B at 1, again, loop within itself. So it starts with B, but B closure is BC. So the final path will be BC. And for C, it's just loop within itself. And C at 1, loop within itself. So this is the final transition considering the epsilon. Okay, so let's start with A. Okay, so since A is equivalent to ABC, so this will be considered as ABC, will be our initial state. So at ABC, where will it go at 0? So BC union will be BC. Okay, and then afterwards at 1, ABC union with BC and C, since BC is part of ABC and C is also part of ABC, so therefore ABC at 1 will just loop within itself. Okay, so next would be we have a new state here which is BC, so that will be our next state that we need to to check the path. Okay, so at B at C, so at 0 it will just go to C, and if it's 1, BC at union C is BC. Okay, so we have a new state here which is just C. Okay, so if it's 0 it will just stay with C, and if it's 1 it will just stay with C. Okay, so this is the final transition table for DFA since all states have path. Okay, so now let's draw the DFA. So ABC will be the initial state. So by the way, so the RC is the final say if it's included on the new state. Okay, C is part of the new state. So that new state will be a final state. So therefore ABC, BC will be a final state. Okay, so ABC, if it's 1, loop within itself. If it's BC, if it's 0, we'll go to a new state which is BC. And at BC, if it's 0, go to C. If it's 1, we'll loop within itself. At C, any value, loop within itself. So we're going to combine all, okay, all state here to form a new state. Okay. So ABC is a new state, BC is a new state. Okay. So this will be our final DFA.